Alright, so this is getting to the advanced stuff where we talk about proving the circle theorems we've been using so far. So hopefully, because we're doing this advanced stuff, you already know inside out this theorem that goes the angle at the center is twice the angle at the circumference, and you can see that this thing at O, so COB is the angle at the center, and CAB is the angle at the circumference made up of this tiny a and this tiny b. Right, so we're going to prove that that rule is true, that the angle at the center is twice the angle at the circumference. And the first thing you do is you draw it out, the usual kind of standard format, no funky format that you can put it into all sorts of funky formats, but just a standard format, right? And then you cut it into two with a dotted line like that. So from the center, go to the corner at A, just a dotted line, and what you get are two isosceles triangles. So this is trying to do it in a very generalized format, so you can do this with any situation pretty much. When you've got the angle at the center situation with the angle at the circumference, you can take your drawing, doesn't have to be perfect because this is trying to show you a general situation, and you cut it in half and you get two isosceles triangles. Now we call this angle A, small a there. So because it's isosceles, and we know it's isosceles because this is a radius, that's a radius, obviously they're the same length because they're part of the same circle. So that is A and that is A. In the same way, if that's B, that's also going to be B because this radius is there, this length is equal to this length because they're both radius. So radiuses, or radii is a proper way of saying it, radii of the same circle. So that's B, that's B. What does that mean for this angle here, COA? Well, since angles in a triangle add to 180, therefore this angle here, COA, is equal to 180 minus 2a. And this one is 180 minus 2b, because that's a triangle as well, right? So this and this and this add to 360. To get this, therefore, COB, you have to do 360 minus this one and that one. So that's 360 minus 180 minus 2a, which I've written there, and 180 minus 2b. Or you could just say add these two together and take it away from 360, which is the way I wrote it there. So 180 minus 2a plus 180 minus 2b. Put them together and take it away from 360 and you get COB. So let's quickly do that. Let's put this together. That's 360. Yeah? 180 and 180 is 360. And you're going to take it away from this 360. So 360 take away 360 is nothing. And that minus is multiplying by each of the things inside. So let's ignore the 180s because we've already dealt with that. So minus minus 2a is positive 2a, and minus minus 2b is positive 2b. So what we end up with is 2a plus 2b. Or you could say 2 times a plus b to, factorize it. Why did I bother writing it like that? Well, if you look at what we started off over here with, this angle at the circumference was just simply a plus b, yeah? And then we found out that COB, or the angle at the center, ended up being 2 times a plus b. So basically we proved it. We've said that's 2a plus b if that starts off as a plus b. So therefore the angle at the center, COB, is twice the angle at the circumference, CAB, and your proof is done.